Hi and welcome to problem 4.1. In this exercise, we want to calculate the expected excess loss, the mean of the maximum of x minus d and 0. So what do we assume in this exercise? Well, first of all, we assume that x is gamma distributed with parameters alpha and beta. So what does this mean? This means that the density of x is given by beta to the alpha divided by gamma of alpha multiplied by x to the alpha minus 1 multiplied by e to the minus beta x for alpha and beta greater than 0, I guess. And what do we have apart from that? Well, they say let fg denote, so let the distribution function be denoted as such. So fg with the dot, so the dot just denotes the argument. So if we had the probability of x less than equal to x, it would be an x that was there. So after the semicolon, we have the parameters. So how we read this is it's the distribution function of the gamma distribution with parameters alpha and beta evaluated in whatever we put here. So actually we can denote this density function a little bit differently. We can denote it, so exactly this density function should be denoted as the density of a gamma distributed variable with parameters alpha and beta evaluated in the first argument. Okay, so what do they say now? They say let D be a deductible. So let D be greater than 0, be a deductible. So this is also what we call in Danish the stilrisiko. It means if the deductible is 1,000 on your bike insurance and your bike has a value of 3,000, then you pay for 1,000 of the loss if the bike is stolen, and the insurance company pays for 2,000. So what they want, so the goal is to find the expected excess loss, just given as x minus d plus. So let's just try to understand this notation x minus d plus, right? If we just have a normal little x, the way you should understand this is that if x is smaller than d, then this is just equal to 0. And if x is greater than d, then this is equal to x minus d. So it's kind of like the positive part of x minus d. Normally, if we, for example, have g of x plus, then what we mean is if g of x looks like this, then g of x plus looks like this. So it's just the positive part of the function. Now, in order to understand this properly, we should probably also write it up using a couple of other methods. So as some of you mentioned in the during the lesson, and also as Christopher has mentioned in his hints, this is also just x minus d in the case that x is greater than d, and 0 otherwise. So we can just write in an indicator function instead, and this will be quite useful just in a second when we try to integrate this function. So another thing that we should probably just recall before we get started is what is the definition of the mean value of a transformation of a stochastic variable. So if this exists, then the mean value of g of x is equal to the integral of g of x multiplied by the density of x with respect to x over the entire real axis. So if it exists. And that is something that we will use to calculate the mean value just in a second. So one last thing that we should probably just bring up anytime we're working with these gamma functions, it's a good idea to just remember this one last formula, which is that the gamma function evaluated in alpha plus 1 is equal to alpha multiplied by the gamma function evaluated in alpha. So there is this kind of funny, what do you call it, relation between the gamma function in one value and then the same value plus 1. So here we need to assume that alpha is strictly greater than 1, and actually I also think that we need to assume that here in the density function. So alpha is assumed to be greater than 1, or else this thing up here won't really make that much sense. So that was that, and we will start the calculations in the next video.